Okay, so this is our notes on 5.1. So we're going to be working in our flip book that says Solving Systems of Linear Equations. We're specifically working on the Solving Systems by Graphing tab. So on the back of the cover tab, when you open it up, it gives this example. I'm going to go ahead and graph everything in two colors. So I'm just going to make this one be orange. So we're going to graph the equation y equals 1/2 x. So there's nothing out here. So it's like having a plus 0. That means that the y-intercept is at 0. So go ahead and put your point here. Now your slope is 1/2 and it's positive. So that means we go up 1 and to the right 2. So from that point we go up 1 to the right 2. Do it again. Up 1 to the right 2. Okay, we can also consider the continue the pattern backwards the other direction. And then we're just going to do our best to draw a straight line. Mine using this tablet aren't great, so do try to use a ruler. It'll make your answers more accurate in the end. Okay, so now I'm going to switch colors. Let's do, how about purple? So we're going to do this equation down here in purple. Now, you can use either cover-up method because it's in standard form, or you could write it out and you could rewrite it in y equals mx plus b form. So we want to get y by itself. We're going to subtract the x. All right, so that gets us y equals, now write negative x first and then the positive 3. So it's negative x plus 3. So that tells me we have a y-intercept at 3. And the slope here is negative 1. That's what's in front of the x there is a negative 1. So the slope is negative 1. Think of it as negative 1 over 1. So the top number is the rise, meaning how many you go up or down. Because it's negative, you go down 1. And then the bottom number is positive 1, so you go to the right one. So from this point at 3, you go down 1 to the right one, down 1 to the right one, and so on. All right. And that's where we're going to draw our line through. I put a lot of points because it's really important to continue your lines all the way across and be exact on this, because where our answer is when we're doing this, where we find our answer is where the lines intersect. So the lines intersect right here. That point that they intersect at is our answer. So that is the point 2, 1. And that's our answer, is the solution of the system's equation is 2, 1. Now we could check by plugging it in. So it has to work for both of them. So if you plug it in for x and y, 2 plus 1 is 3. And you ask yourself, does 3 equal 3? Yes, it does. And then if you plug it into the top one, 1 is y, x is 2. And 1/2 times 2 is 1. Does 1 equal 1? Yes, it does. So it should work out for both. That's how you check to make sure the equation is correct. Okay, let's try this one. It doesn't matter which line you graph first. I'm going to go ahead and graph this bottom line because it's already ready to go. So it starts at a y-intercept of 2, and then its slope is negative 2. So think of that as negative 2 over 1. So negative 2 means down 2. 1 means to the right 1. So from that point, down 2 to the right 1, down 2 to the right 1. I like to keep going, and then I extend my pattern up. The points should always fall in a line. And then we're going to, you know what, I'm going to try to use the tool to draw a line, just because it's not going great today. Okay, let's see how we do here. Okay, so there's my line. That's not terrible. And let's go ahead and figure out our other equation. We'll switch back to orange. So this equation I'm going to write down here. I like it in y equals mx plus b form so I can graph. So I'm going to divide by 2. So that gets me y equals negative 2x plus 2. So I start at 2. I go down 2 over 1. And what you notice about this line is it's falling on the exact same line that it was. Do you see how the pink line and the orange line are falling on top of each other? So that means they're the exact same line. So the word for that is actually called coincident. So they are coincident lines, which means they are the same line. That's what you say, those coincident lines. And those will intersect forever, like they have intersections all the way everywhere they touch. So that's infinitely many solutions because they have infinitely many intersection points. So we write infinitely many solutions. Okay, so now that's in our flip book. I also have this practice page. I thought we might do a few on here. So it says graph each system of equations. So let's just try this first one right up here. So I could graph using the cover-up method, or I could just go ahead and get in y equals mx plus b form. So if I go ahead and get y by itself, first I'm going to subtract the 2x. I'm trying to get y alone. So I have 2y equals, I have negative 2x plus 4, because 4 is positive. Now divide everything by 2. You get negative x plus 2. So the y-intercept's 2. The slope is negative 1. Think of it as negative 1 over 1. So go down 1 to the right 1. Down 1 to the right 1, and so on, until you are ready to draw in your line. Okay, let's go ahead and graph the other line. Let's just switch to a different color. I'm only doing separate colors so you can really see the difference so that you can tell which equation I've been working with. So, okay, first of all, I'm going to take this and I want to just go ahead and reverse this. So I'm going to put the negative 6 minus 2y on the left and the 2x on the right. All I'm doing is switching these two sides because you guys tend to like the y to be over on the left side. So now if I want to get y by itself, I need to move that minus 6. So I'm going to add 6. Okay, I get negative 2y equals 2x plus 6. So now to get y by itself, I'm going to divide by negative 2. All right, that gets me y equals negative x, and then 6 divided by negative 2 is negative 3. So we start at negative 3, and then our slope is negative 1. So once again, down 1 over 1, down 1 over 1. We can go up in the same pattern also. Okay, so if you look at those lines, they are parallel. So they will never intersect. And if they're not going to intersect, that means they have no solution. So lines that are on top of each other are coincident lines and they have infinitely many solutions. And lines that are parallel never intersect, so they have no solution. Okay, let's try this one. So pick a color and let's go ahead and let's do y equals negative 2. That's a horizontal line. There's no x. So that's a horizontal line. When it's just y equals the number, it's horizontal, going through the y-axis at the number it's equal to, so going through at negative 2. Okay, so now let's go ahead and let's do this one. So the first thing I'm going to do is try to get y by itself. So I'm going to subtract 3x. So I have negative y equals, write the x first, so minus 3x and then minus 1. Now, in front of y is a negative. That's not just a negative, it's a negative 1y. So divide everything by negative 1. So we get y equals, that becomes 3x, and negative 1 divided by negative 1 is positive 1. Okay, so 1 is your y-intercept, start there. And your slope is 3. Think of that as 3 over 1. That means up 3, since it's positive, and to the right 1. So up 3 and to the right 1. Another way you can do it is negative 3 over negative 1 is the same as positive 3. And if you think about that, that's down 3 and left 1. So think about that. Is that in the same pattern? If you go down 3, left 1, do the points still fall in a line? They do, so it works. If they're not falling in a line, then we're doing something wrong, and we just need to kind of pause and figure out like what's going on. Okay, so that's not perfect, but that's my line right there. Go ahead and kind of get it lined up a little better for you. All right, cool. So now remember, where your answer, your solution is where the lines intersect. They intersect right here. So think about what point that is. That's the point negative 1, negative 2. And that would be my solution. Okay, let's go ahead and try one more on this practice page. So if we start with this equation right here, I'm just going to write it down here, 3x plus y equals 3. What is the equation when you get y by itself? First, you're going to subtract the 3x. All right, that gives us y equals, we have negative 3x plus 3. Okay, go ahead and graph that. So start at 3, and then your slope is negative 3. Think of that as negative 3 over 1. Down 3 because of the negative, to the right 1. So down 3 to the right 1, down 3 to the right 1, and so on. All right, we're going to put a line there. I'm going to use my mouse to get it a little better. Use a ruler to get it looking good. Okay. That looks like about as good as it's going to be. So let's look at our other equation. And our other equation, I also need to change. It is also something we could do cover-up method on. Or I think a lot of you guys really like y equals mx plus b better, so I'm kind of staying on that method because it seems to work for you guys pretty well. But cover-up method would also be a great one and maybe quicker to use here. So if you did cover-up method, let's try that just to try. So if we plugged in 0, that'd be like plugging in 0 for x, you'd cover up that 2x, and you'd be left with 2y equals 4. And when you divide by 2, you get y equals 2. Okay, so now if you went back and this time covered up the y, that's like plugging in 0 for y, you get 2x equals 4, and that's 2. So you have points at 0, 2, and 2, 0, and that's where your line's going to go through. But once again, if you like to just solve for y equals mx plus b slope-intercept form, I'm fine with that. I think it's a great strategy. If you don't want to do cover-up method, you can always just rewrite each equation as y equals mx plus b. It's kind of your choice. Okay, so now let's look at where they intersect. This looks like a decimal. It's right there. This point that they intersect is right there. So we're looking for that. So that point looks like to me it's over a half and up 1.5. Or 0.5, 1.5. It just depends on how you want to write it. So either one of those would be fine. Okay, so remember when graphing, you're graphing both equations. Just take it easy. And if they intersect, then the point where they intersect, that's going to be your solution, and they'll have one solution because lines can only intersect one time. Lines can also never intersect if they're parallel. They will have, sorry about that, no solution if they are parallel. And if they are what's called coincident, which is where you have a line and then another one right on top of it, then that's going to be infinitely many solutions because they intersect forever, which is infinitely many times.